Gas turbines are changing the way we fly. Only the gas turbine is light enough and powerful enough for the high-speed aircraft of today. The best known use of the gas turbine is jet. But gas turbines are also... All heat engines depend on the same principles. They burn fuel. They change a part of the heat the fuel produces into work. They waste the larger part of the heat in the exhaust. To change heat into work, engines have to use something which expands when heated. The steam engine uses steam. The gas turbine uses air. The change from heat to work can be demonstrated by a simple experiment. Here is a cylinder. One end is closed by a thin plastic diaphragm. Here is fuel. The fuel mixes with the air in the cylinder and burns. The heated air expands and does work. Hot expanding gases pushing against a piston do work and drive a gasoline engine. The push can be changed into rotary movement by a connecting rod and crank. To power continuously, this kind of engine needs a carburetor, an ignition system, valves, and valve operating gear. Power is produced in a series of pushes. The piston is continuously accelerated and stopped. Millions of engines like this are in use throughout the world. They serve us well. But the more power they produce, the more complicated they become. The gas turbine is much simpler. Instead of using the pressure of air, the air is allowed to escape through a nozzle. A bladed wheel is put in the path of the airstream. As the air is heated, it shoots out of the nozzle. Heat energy has been changed into kinetic energy, that is, into movement energy. And the wheel changes movement into torque, or turning power. Here, the supply of air is limited to what the cylinder contains. To produce continuous power, there must be a continuous supply of air. The air has to be supplied under pressure, so a certain amount of work is needed to compress the air. This extra work is more than justified by the increased energy in the stream of air. Gas turbines need a way of compressing air, a way of mixing fuel with the air and burning it, and a way of turning the gas energy produced into work. Here's a typical gas turbine, one for driving a propeller. Take away its starter motor and other accessories so that the three basic parts can be seen: the compressor, the combustion system, and the turbine. This arrangement of the three basic parts in line is the simplest possible. The air is taken in at the front through an intake round the propeller hub. The air goes through guide vanes into the compressor. Gas turbine compressors may be of several kinds. This is an axial compressor. It can